Good evening, everybody. So I think we will start because we are already 8 minutes past the deadline, and I'm sure more people will join us as the session goes on. So thanks everybody for coming on board to today's webinar, Blockchain for Good Ideathon. And today we have a very special speaker. We have Rajesh Kumar Lamtu, who is joining us today as a resource speaker. Rajesh is the founder and CEO at Track Genesis. He is a certified blockchain architect, and Rajesh is based in United Kingdom. Rajesh has been a CEO now with this company for the last 3.5 years, and earlier he was a director with Metasoft Limited. Before that, he was a senior developer with Advanced Business Solutions, and earlier to that, a programmer with the Trapeze Group. Rajesh comes with a lot of experience on blockchain. And in fact, Rajesh has been a resource speaker for us earlier in our other blockchain webinars. And we have always had very, very good strategic viewpoints on how blockchain should be used. And we are very grateful and lucky to have Rajesh here today. So Rajesh, thank you so much for accepting our invite.
Well, thanks, Deacon. It's a pleasure. I'm not sure. Looks like the video is got, stuck. I'm not really sure. Is it my side or like it?
He has lost his
Saurabh?
Yeah.
Sir is having some technical difficulty?
No. I guess it was at your side.
But am I visible right now?
Yes.
Yes, you are.
Fantastic. Yeah, thank you. So Rajesh, over to you. I will let you take it forward from here, and I'll just be on mute. So thank you again, Rajesh. Thank you once more for coming and joining Binance Blockchain for Good Ideathon, and where you'll be speaking on organic and clean farming. So please take it ahead, sir.
Oh, thanks very much, Deacon, for this opportunity. I'd like to share my screens if that's possible. Let me see.
Saurabh, please.
You can.
Yeah, because I prepared the presentation. That's much easier. All right. Okay.
Yeah, you can, sir. You can try.
Oh, can you see my screen now? Oh no, sorry. That's okay. Can you see my screen now?
Yes.
Yes.
All right. Okay. Yeah, thanks, Deacon and Saurabh, for the opportunity. As Deacon said, my name is Rajesh. I'm founder of Track Genesis. It's a software company. We mainly use blockchain technology to build the business applications. And we are based in the UK, and our operations are mainly in UK and Europe. But we have an R&D team based in India. So we did multiple projects with the food and drink, fashion, and other industries. So today I'm going to talk about the application of the blockchain technology in clean and organic farming. So this presentation, the way I prepared is to first explain a little bit about the background of the blockchain technology first, and then it comes to the problem domain of this, the organic farming and how we can implement this blockchain technology in that side. And then talk a little bit about the pros and cons of blockchain technology. And then finally talk a little bit about how we can utilize this blockchain, how we can integrate the blockchain technology with our current web application, current technology. How does that sound? Is that okay? Okay, hope that's okay.
Yes.
so okay, I'll start the presentation. So yeah, as I said, it's the application of blockchain technology in clean and organic farming. So first I'll start with the background. So the blockchain technology, when we are talking about blockchain technology, everyone will think about, the first thing comes into our mind is cryptocurrency. So excuse me. So I'll start with that first. So in this picture, the top sorry, somebody say something, or is it okay for me to go ahead?
You can go ahead.
All right, okay. The one on the left you see is a pay slip. So what happened in the olden days, when you're working for a company, you normally get your salary in an envelope, and the pay slip will be attached on top of it. That's how I got my salary in the first employment. It's a great feeling, when you get the salary, you get the currencies, and then you can put it in your wallet. You can go to the shop and you can buy stuff, and you actually give this real currency. So all transaction is real. You pay using your cash. And then things have changed. Banks became very popular. And what happened is like the company have tied up with the bank, and then they transfer the salary to their bank account directly rather than giving the pay slip and giving the hard cash. So what bank did is, if you go to bank and take a bank account, they will give you an account number and they will add your account number into their ledger. And then once you get the salary, they will add a new transaction to that ledger with your account number saying that, okay, salary credited 10,000 or whatever it is. And then you make a transaction. So that money goes into from your account to another account. So it's all electronic transactions happening. So money is going up and down. So the number is going up, number is going down. So basically no real cash transaction is happening. Like it's the numbers, the account is changing. And what they do is they take some commission for this transaction. Then technology change evolved, and then more and more like the fintech application came, Apple Pay, the Google Pay, and a lot of other things, like PayPal and everything came. So again, like they do the same thing, like they make it easy for transferring money between accounts, and they take a cut of this transaction. So if you imagine, like if you're transferring your money from one country to another one, what happens is like it takes a lot of time. Like maybe sometimes it takes a few days to the money get arrived to the recipient's account, and also they take a lot of money for transaction fee. But all they do is just reduce the number from one ledger to the another ledger. The reason they are taking is because they are monitoring this, they are regulating this software, or the bank is they're responsible person for like handling your account. So at this point, the guys, the Bitcoin guys, Satoshi Nakamoto, who we don't know like whether it's a guy or like group of people, or we only know the name. So they thought about like why we need to give a commission to a bank for making this transaction and also taking a lot of time. Why can't we make one single ledger and then give add everyone to that ledger and then allow them to like transfer money each other without the regulation of a bank or a government? The thing is like, because right now like the currency is the value of the currency is based on the different factors, like the government, the stability of the country, and the economy of the country, and also the money value can go up and down. Like if our current country's economic status is not stable, we are seeing that in Sri Lanka and different other countries, Venezuela, and then like sometimes like if the war comes in the Russia and Ukraine, like sometimes like the currency might not be like usable. So they thought, okay, rather than relying on the country's own fiat currencies, so why can't we make an electronics money system, And that's where like the Bitcoin came. So what they did is, rather than keeping the ledger, but the bank, like they created a big ledger. I mean, I'm trying to like make it like more simple way. Okay, it's much more complicated than that. So basically, they have a big ledger, and then that ledger will have all our account numbers. So the account numbers in Bitcoin terms we say is public keys. And then when we can make transaction between these accounts, and this all transaction, everything is managed by this code, computer programs or smart contracts. So that's where the Bitcoin came, and it was a great invention because there's no intermediary. So there are risks involved in as well. But the problem is like, how do we make sure like these transactions are not tamper-proof, or like it has to be immutable, because otherwise like someone can go and change the transaction. So they wanted to utilize a technology that made this transaction is immutable, and then also like they wanted to make sure like it's transparent to everyone. So they don't want like someone to hack it and like change the bond. So before going that, like I'll explain how the transaction stored in a normal database or like a normal banking system and the blockchain system. The blockchain is the technology Bitcoin used to store these financial transactions. So this is a normal, typical, bank application, or like any typical software databases works. So we create a new transaction that creates the record, and we add another transaction, that record comes to the next line, and it's adding like one by one. And then if you wanted to make a change to the previous one, if you have access to the database, you can do that, no problem at all, because these transactions are not directly linked. I mean, yeah, there are links, but actually, technically, we can actually make this not a problem. But in blockchain, it works completely different way. So in blockchain, for example, if you are using Bitcoin, if you're making a transaction, what they do is like they take a bunch of transactions and put it into one block. And then when the next transaction comes, they take another bunch of transactions based on the block size and put in another block. And then these two blocks will be linked using a link, and that link is based on this data inside this block. So basically what we say is we hash that data and then using that hash to link between these the block. And then when more and more transaction comes, we create more and more block, and all the blocks are linked to each other. And this is called blockchain. It's like a chain of blocks, contains all this transaction data and linked using a hashing algorithm. And the benefit of this blockchain is because if you wanted to change the data in the previous block, it is not possible, because if you change the data, this link will be invalid because this link is made based on the data inside this block. So that is not possible. You can't really go back and make any changes. So that made this blockchain immutable and tamper-proof. And then the next thing, what they did is they take this blockchain and store into multiple computers, tens of thousands of computers. So that made it distributed system, and the same blockchain make it distributed or decentralized. So that creates it's transparent. So everyone can see that what's happening there. And then if someone wants to hack it, which is considering the current computational power, it is not easy. But even though like someone hack into one system, and if they change, the other peer have the real one and they won't accept that transaction. So unless like you change, you can hack more than 51% of this, we call it node, the computers, it is not possible to hack that system. So that made this blockchain network tamper-proof, transparent, and like immutable. So then what happens is like everyone think, oh, that's a great idea, but we use this mainly in the financial transactions. But why can't we use it in the real world scenario? Because the immutability and transparency is two great features. So why can't we use it in? But when they created the Bitcoin, they designed that blockchain mainly based on mainly for these financial transactions. So the next Bitcoin the blockchain network or the cryptocurrency or whatever, like the framework comes is Ethereum. Ethereum is also a public blockchain network, same as Bitcoin. They have their own currency called Ether. But at the same time, what they did is they allow our computer program. They allow us to install our own computer programs on top of that blockchain network. They call it as smart contracts. So what happens is like we can create our own computer program and install on top of the Ethereum blockchain network, and we can connect our application, software application, to that smart contract, and we can store our information into that blockchain network. So that Ethereum started like a new revolution of like storing the business application and business data into the blockchain network. Now you got a vague idea about like what is blockchain, and then how that evolves. So now we go into a real use case, the farming, how we can utilize the blockchain technology in the farming. The organic and clean farming is actually it's a big thing, like in many countries, because I remember when I was young, like we used to go to the local grocery shop, and then you buy fruits and vegetables or like gross things from the local shop. And the local shop, what happens is like all the things coming from locally, like the rice may be coming from the fields in the local field, and then the people like doing this, the transfer, all this processing, they're all local, so we can trust them and we can buy them. But what happened is like the globalization came, and then supermarkets came, and the supply chain became bigger and bigger and bigger, and then it was actually almost impossible to trace where that thing's coming from. And then how do we know that like the thing that we are buying is genuine, like it's not using any pesticides, it's clean? It's very difficult because we don't have access to that system. So normally like the supermarkets, they only have access to their next suppliers, but they don't have access to up to the farms. And then there are regulatory bodies, but we don't know like whether like maybe they say okay, it's ISO certified or whatever like certifications, but how do we know as a consumer, how do you know like they are not using any of this pesticide, it's clean as it's organic? So what we can do in this case, we can utilize this blockchain technology and make sure like all this information transparent to everyone. So how do we do that? Like we first create a network, a blockchain network, and we allow each and every stakeholders into that blockchain network. So for example, farmer will be a part of this blockchain network, and the regulatory boards, maybe it's a government or somebody else, and whoever like regulating that thing, they will be a part of this blockchain network. And then the processing unit or like whoever like handling these things, they will be a part of it. And the shop owner will be a part of this blockchain network. And then what happens is when someone like take the scopes out, like when the harvesting happens, or they input their information along with the photo or whatever into this blockchain network, and then what we do is we capture the geolocation of that of the farm, and then we can make sure that's coming from that particular farm. And then again, like when they started like farming, they will have to consult with this regulatory board, like, and they will have to make sure like they are using the the allowed they're not really using like chemicals or pesticides which are not allowed to use. So what I mean, it's all based on like the government also have to have some sort of control in this one. So what normally happens is like in some countries, like if you wanted to buy the pesticide, you need to have a license and you need to go through a regulatory board. And in that case, when they buy the pesticide, the regulatory board will store that information to the blockchain, saying that, okay, look, this farmer bought this many kilograms of this pesticide or whatever, or maybe they are buying this one, and then these guys will be inputting this information into the blockchain, so it will be visible to everyone. So we know that like these guys are using these kind of things, like they're not using any harmful pesticides and all. And once they have like the crops ready, then they input that information along with the geolocation, and once that goes into the next stage, again like in the block, they input the information with that stage. And then finally, once it like become like a product, like we create a unique QR code into that product, and then a consumer can scan the QR code. They can see the whole information in the mobile phone. They can see that, okay, when that harvest started, what are the chemicals they use and where this comes from, and more importantly, we can trace all the things. We can make sure that it's coming from local. Maybe you can ask why can't we do it in a normal technology? I mean, the databases. There are like some limitations in database. The first thing is like we can change that. Once you input the information, you can change the data later on. And if for example, like some outbreak comes, something goes wrong with one batch, they can still like go and change the batch number and then still sell that one. So how do we make sure that they're not actually changed anything? So the blockchain, it's not possible. Again, in normal software systems like centralized databases, each stakeholders have their own system, and then it is not easy to integrate. Two problems: one, technical problems, they may be using different technologies, and it's not easy to integrate like if you're using different technology. And the second thing is if there is competitors involved in the supply chain network, they don't want to share the data each other. Whereas if it is in the blockchain, it's transparent to everyone. It's real-time information goes to the blockchain. Nobody will be going back and change this information later on stage. And then consumer can also make sure like the things that we are seeing in the information is accurate. So that's one of the main applications in the blockchain applications in farming. And this is one of the projects we did recently. Mad Potato is a local business. They are selling local farm producers in Scotland. So what we did is like we worked with Mad Potato, and then we went to the farms. Most of them were organic farms. They're actually much more than organic, because the organic farms, which means like if you are if you're using like some certified, there are some classifications, but these guys were actually much more than the organic. They were like purely using like the genuine they don't use any chemicals at all, basically. And what we did is like we input
blockchain
sorry, are you asking any questions, or can I go ahead?
Yeah.
Okay, sure. So what we did is like we we made like all this the farmers into this blockchain network, and then we allow them to input the information when they were like taking these producers, and then we captured the geolocation of this farm, and we captured the geolocation of this the distributors, and then finally we captured the geolocation of the shop they are selling, and we created the foot miles it travels. And then when consumers scan this QR code, that's what like you're seeing is this is the app we created, and then that app will show a complete journey of this fruits and vegetables. It shows that where that foods come from, and how many miles it traveled, and what are the information like related to that product. And this is one of these exhibition we did recently with this Mad Potato, and these are all like local producers. So yeah, basically we did that one. And the other thing, most of you must have heard about the negative publicity of blockchain. Yeah, people will be saying like, yeah, you're talking about sustainability, but the blockchain is actually notorious to sustainability because blockchain creates a lot of, blockchain uses a lot of electricity. That is true. The thing is, when we are talking about blockchain, everyone think about Bitcoin or Ethereum. Bitcoin and Ethereum uses a lot of electricity. The reason, I mean, you can see this graph. Bitcoin uses more electricity than the whole Argentina country uses, which is not really good. And why they use this is because Bitcoin is not regulated by any government or any regulatory board. So it's a public blockchain network. So every transaction, it goes to the blockchain network. We need to make sure that it's validated properly. And that validation process is a bit more computational power required. So we call it mining. I'm not really going too much detail into the technical detail into the mining, but because of that mining, it takes a lot of electricity. That is causing this one. And why people mine? Because if someone mines and someone add that transaction into the blockchain, they get some reward from Bitcoin. So currently the reward is 6.25 Bitcoins. It's about more than I don't know, like a USD. This is too much. Like it's too much money. So people are, because the reward is too much, people are more and more people like coming to the mining, and it causes a lot of electricity. But then you can ask, like, yeah, you guys are talking about the sustainability, then why you want to use this blockchain technology? Because this is against the sustainability. You're right. We are not really using public blockchain network. So there are different types of blockchain networks. The distributed ledger technology, basically another word of blockchain we are talking about. Like there are like a public blockchain and private blockchain and a consortium type of blockchain. So private and consortium is almost about the same. So what's the main difference to the public and private? The public blockchain mainly used for cryptocurrencies, right? Like mainly, Ethereum, Binance, so, like all of them. The Binance is slightly different, but Ethereum, Bitcoin, they're all like public blockchains. But there are private blockchain is mainly used in the bigger companies, enterprise level applications we use in private ones. So that doesn't use mining, so which means like it's not actually against the environment. So I told about like public and private, and this is a blockchain trilemma, because the blockchain is a great technology, but like all the technology have pros and cons. So this is actually, I would say, like it's a bit outdated because it changed after. So normally what this is like, you can't achieve three at the same time: security, decentralization, and scalability. So for example, Bitcoin is a great example of in a blockchain, an application of blockchain technology. So it's highly decentralized, which means like tens of thousands of people hold this data of blockchain, the Bitcoin. So it's very decentralized. It's not like keeping in one place. It's in tens of thousands of people's computer, and it's highly secure because it uses the mining and lots of other security measures. It's highly secure. But when it comes to the scalability, that's where the problem is, because in Bitcoin they design in a way that every blocks get created in 10 minutes time. So they actually makes the mining in a way to make it difficult, that like you have to do it at least 10 minutes to create a new block. So because of that reason, you can't really create like lots and lots of transactions at the same time. The transaction per second is slower. And Ethereum originally was like that, but now they are moving into Ethereum 2, which is more scalable. So that's why I said that it's not exactly correct at the moment, because more and more technology is evolving, and we can now use the blockchain technology, considering all this the benefits. So the next one is this types of blockchain for developing applications. So the first one, Hyperledger Fabric. This is a private blockchain framework we use in enterprise level. So we can create business application using the Hyperledger Fabric, and the data doesn't go to the public, but it goes to the people inside that blockchain network. We call it like a permissioned blockchain network. It's originally started by IBM, and then once they mature that, like they gave into Linux Foundation. Now it's open source. You can utilize this Hyperledger Fabric to create your own blockchain network. The second one is Hyperledger Sawtooth. It used to be Intel's project, and then again, like they moved into under the Hyperledger umbrella, and it's on now looked after by the Linux Foundation. It's an open source one. The R3 code are mainly used in insurance and banking sectors. It's owned by R3, and it's maybe we can say like it's a consortium type of blockchain network. And Ethereum, everyone knows that is a public blockchain network. The reason I didn't put the Bitcoin is because this is mainly for this blockchain network we use for building business applications. And of course, you know about Binance. Binance is also like we can build business application on top of it. Same like Ethereum. The Ethereum and Binance, you can use the Solidity programming language to write the smart contracts and install it and use it with our business application. Solana is a very good one. Like it's getting a lot of traction recently. It's very fast and a more scalable one. And Polkadot is an interesting one. They call it themselves as it's actually a layer 0 blockchain network. Polkadot has a framework called Substrate, so we can, using that framework, we can create our own blockchain networks. And also it uses now if you use Polkadot, we can interchange the assets between different blockchain networks. I'm not really going too much into the detail, but it's a great one. Again, Cardano is also like a very highly scalable blockchain network. Polygon is a layer 2 blockchain network, which means it's much faster than Ethereum, but it connects with Ethereum to make sure like it's tamper proof. Like we call it layer 2. You get all this benefit of this blockchain network, but it's much faster, and the transaction fees is nothing. It's very cheap. And Algorand, again, like it's another blockchain network, is gaining traction a lot these days. So basically, there are lots and lots of blockchain networks you can use, but I just picked like a few of the very popular ones, just to give you an idea about like the blockchain is not just Ethereum or Bitcoin. There are lots and lots available here. Now, how do we create the blockchain network and blockchain up? And how do we use this blockchain up in a framework with our current web application technology? So that's what like I'm trying to explain. This is a very basic diagram. In reality, it's actually much complicated than that. So this is a typical diagram of a merge stack application. It's a JavaScript web application. So what happens is like we have front-end applications. The React is a front-end JavaScript framework, and that's where like we input the information. Maybe like if you input the name, address, or whatever, like, and then you click on submit, that goes to a back-end server-side application. There's Express Node is JavaScript frameworks, and they do some processing and they store that into a database. And this is a MongoDB. It's a token-based database system. This is how the typical web application works. When it comes to the blockchain, what we do is we simply remove the MongoDB and then we put the blockchain network in there. So rather than going to the MongoDB, the information go to the blockchain and retrieve from blockchain. And at the same time, the same application, you can connect multiple applications to the blockchain network, and everyone gets the information real time. The diagram is very simple, but in reality, it's much more complicated because we need to have a blockchain network up and running. We need to write smart contracts and install smart contracts on top of the blockchain network, and we need to connect the smart contracts along to our web application using SDKs and APIs. So it's a bit more complicated, but in a very high level, this is how things work. Yeah, I mean, what I thought is like I give you some explanation about this technology and the background and this application and everything, and then we can have an interactive sessions, like we can ask questions and then make it more interactive. So yeah, man, thanks for your time, and then yeah, feel free to ask any question. We can make it like more interactive. Thank you.
We have one question. So can you please read out the question?
Oh yeah, sure. Sorry,
So like, the question is that can we build seed supply chain using Hyperledger Fabric private blockchain network?
Yeah, sure. You can build using the Hyperledger Fabric. What we need to do is first we need to decide who are the stakeholders, and then we build the Hyperledger Fabric private blockchain network, and then it's first we need to understand like what are the data we are going to try, what data you're going to input into the blockchain network, what data we are all interested to see, and then we see like who are the stakeholders, who are the ones like inputting the data, and then we create a network and create all these nodes and link between link all these stakeholders into the blockchain network, and we can use that. Yeah, we use Hyperledger Fabric for our projects. It is possible. Anyone else?
For that answer.
Yeah, all this, like, I'll just share this one, so then we can talk this. Yeah, feel free to ask questions. You know, like make it more like interactive.
Please, guys, ask questions. This is a good opportunity for you guys to learn from all the experts we have over here. Don't lose this opportunity.
Yeah, the thing is, like, if I just give you information, you know, one after another one, you don't learn anything. So that's why I normally try to like make it this presentation in a half an hour and then leave the rest of the time for interactive sessions. And when you ask questions, you know, you understand more.
I think what we can do, Rajesh, is so because a lot of the people on the call tend not to ask questions. So we do ask them to probably write into us. And if there's any questions, we pass it on to you.
Of course, yeah.
But
yeah,
but on a side, I was going through your website and I saw that you're doing something with a brewery in Scotland.
Yes,
so, yeah. You want to share a bit about that, because that sounds like fun.
Yeah, sure, of course. We're working with a brewery called Brewtown. They're making like craft beers in Aberdeen, in Scotland. So we are implementing our blockchain framework with their supply chain products. So the consumers can actually see where the things are coming from. It's going to be a cool project. We are actually launching this week. We are working really hard. That's why I said, like, I'm very busy these days because we need to launch that thing. So yeah, we launched fantastic. Like a few projects already with this food and drink sector, and also working with fashion companies showing these traceability things.
Fantastic. I mean, traceability is the new keyword right now. Everybody wants to know where the food, drinks, clothes come from. So
of course, I mean,
yeah, you got some more questions. Saurabh, do you want to read out the question?
Okay, I will tell. How to interact the physical or analog data on blockchain? So
physical, yeah. I mean, the date again, like when we are like implementing the blockchain technology with the clients, first we need to understand like how the data comes. Like the analog means like maybe like if they're using any of these controls, we need to integrate that controls with the blockchain. So we'll have an intermediate application there. In blockchain, basically, we store information as a JSON object. I don't know, like a key value pairs. Like we give a key and then we have an object like and based on the key and we store into the blockchain network. So we need to make like some changes before like we store into the blockchain. So if it is a data like it comes like continuously. So we need to make sure like how do we want to store that information with the blockchain, and we can make like some slight changes. Not really changes, but I mean the analog again, like analog. I thought like I didn't fully understand like what do you mean by analog. It's a stream of data coming from a sensor. Is that what you mean? Or, I don't know who asked this question.
Nishan, you can unmute yourself and test.
Yeah, sure. Yeah, physical data. Yeah, that's true. Yeah, okay. That's a good question because there's a scenario, for example, like an ice cream company. Okay, ice cream company wants to make a really good ice cream, and then they wanted to. They're too much into the quality of this product. So what they did is like it's a hypothetical scenario. Okay, so in their business there are different stakeholders: the ice cream manufacturer, and then the milk producer, and then there is someone like who transport the milk from this the farm to this ice cream manufacturer, and then there's a supermarket, they sell the ice cream. So originally they said to the farmer saying that, okay, we need to have this milk and that has to be and it has to be fresh basically, and then that milk has to be kept in a certain temperature before it reaches to this the company. And then the supermarket says like once the ice cream is made, the ice cream has to be in a certain temperature. And then they all agreed that in reality they all agreed on a paper, and then there's no way we can actually. So what we do is like once we get the ice cream, we check the temperature sensor on the truck or whatever, and then that just sounds good, and then we take the product. But we don't know like what's happening in the transportation. So maybe like the temperature goes down a little bit or go up a little bit. Then how do we measure that? And then Even there's no system at the moment. But if we are integrating with the blockchain technology, we can write a smart contract saying that if the temperature is above or below the threshold we agreed originally, we make that batch obsolete or batch, rejected or whatever. So we write that in the smart contract, in computer program, and then the sensor feed the data directly into our system, and the system check the data, the temperature. The data is temperature. It's a continuous streaming temperature, and this temperature is above or below the threshold. Then our smart contract will kick in, and that smart contract will change the data of the status into rejected, and then that status will get returned into the blockchain network, and nobody will be able to change that. In that case, we can make sure that we get the product we originally expected. So nobody will be able to change that, even though they wanted to use that, but they can't do anything because the data is returned into the blockchain. That's one of the scenarios. I don't know whether that's answer your question.
Does knowledge of data structure help in developing blockchain? How can we use Python in blockchain?
Yeah, I mean, data structure is an important factor because again, there are different types of blockchain frameworks. If you're talking about Ethereum, Ethereum is a private public blockchain network, and every time when you are making a transaction into Ethereum, we need to pay some gas fees. We call it gas fees. It's actually a cryptocurrency we need to pay, and the gas fees they calculated based on the functions that runs inside the smart contract, and also the data we stored in the smart contract. And we need to know exactly the data structure, because we can store a number into a number variable, an integer variable, for example. So integer variable. An integer normally takes maybe 256 kilobytes of space. But if you are talking about maybe a serial number or whatever, you don't really need maybe hundreds of thousands of digits. You might need only 2 digits or 3 digits. In that case, you don't really need a 256 kilobytes. We can maybe use a int 32, so 32 bytes of integer, or int 64. So there are different lots and lots of data types available in Solidity programming language. So we need to optimize it. So if you optimize it, then the gas cost will be much cheaper. So yeah, if you wanted to write smart contracts in Ethereum, knowledge of data structure is very important. But if you are using Hyperledger Fabric, it's more like a high-level programming language. We use JavaScript to write programming language in Hyperledger Fabric. So in that case, you don't really need to worry about that because you are using private blockchain network. So there's no gas fees involved in that transaction. So yeah, but it is important. And then the second question was Python, right? Yeah, how can we use Python blockchain? If you're talking about Ethereum, then it has to be written in a certain programming language. Solidity is the most common programming language we use to write the smart contracts. Solidity is a object-oriented programming language. So which means if you know Python or if you know Java, you can easily understand Solidity. Again, you need to have the same knowledge. You need to have a good understanding of data structure plus a good understanding of object-oriented programming. Then you can easily understand this Solidity language. When it comes to other blockchain frameworks, I mentioned lots and lots of blockchain frameworks are available. They have their own SDKs, like software development kits, and that will be interacting with this blockchain network. There is a Hyperledger Sawtooth. They use Python SDK, and again, so Solidity. If you are talking about the Ethereum, that will also have something called web.py. So it's a Python. You can write things in the Python. So basically, if you are writing your software application in Python, any of the Python framework, whether it's a Flask or Django or whatever, you can use that. But there are limitations. Most of them are written. The JavaScript is the most popular one in Hyperledger Fabric and all. But Sawtooth uses Python. I mean, my first project was I written in Sawtooth, and I use Python and Django for that. What's the next question? So do we have study reference we can learn from blockchain network using Hyperledger Fabric? it's a bit tricky actually, because the Hyperledger Fabric is evolving very quickly. When I did a certification course in the Hyperledger Fabric, I'm a certified Hyperledger Fabric developer and also an architect. So when I did my certified Hyperledger Fabric course, it was Hyperledger Fabric 1.4, version 1.4, and version 1.4 was using something called IBM blockchain platform to write the smart contracts and install it on the blockchain network and then test it and everything. And before that, it was something called Composer. That's the tool we use to write the smart contracts. Now it's version 2, version 2.3 and 2.4 now. So things are changing all the time, and the supporting tools are also changing. So I don't know whether you'll be able to find the materials on YouTube, but there are institutes actually teaching the Hyperledger Fabric, and the KB is one of them. Like, they're doing really good these days. I did with the KBA, but again, like, it's a continuous learning. So once you learn, then you can't really stop it. Like, you keep learning that. Anything else, or do you want to add anything? Yes, that's true. Yeah, it's Kerala Blockchain Academy. Yeah, they have some certificate courses, and also they have some free courses available that will give you an understanding about this the technology. And if you are a business person, they have a course called Blockchain Startup. I think Certified Blockchain Startup. That's a collaboration with IITM. Whatever. I can't remember that. Like, it's an institute in Ahmedabad. That's also a really good course.
Good. This was a very interactive session. So great, Rajesh. Guys, any more questions for Rajesh? Okay. Thank you also, Gurunath. Thank you so much. Best resource to learn blockchain. I think Ramanpreet has asked us a question. Best resource.
I mean, I actually don't know, to be honest, because when I was like trying to self-learn these things, normally, like, we get these resources from YouTube or other, like Udemy and all. But I'm not really, yeah, you're talking about the coding part. I understand that. I can't remember at the moment, but feel free to connect me in LinkedIn, and if I know anything, then I can share with you. Because this thing is like, it's changing all the time. And then, yeah, if you're talking about the coding part means like you're writing the smart contracts. The smart contracts is, if you're talking about the Hyperledger Fabric, it would be purely JavaScript. So if you know how to write things in JavaScript, it's easier. But then you need to use some tools to create convert that smart contract into chain code and install it into the blockchain network. And all. It's a bit tricky, but I will have a look, and then if I can find anything, I can share with you. Any particular areas you have doubt? Is it Raman? Okay, yeah. I mean, if you have doubt in any particular area, then I can probably explain Python and Python lead code. Okay, I mean, Python is good because if you know like very well about Python, you must know about the object-oriented programming language as well. Yeah, I mean, you can of course learn blockchain. I mean, the thing is like, if you're a programmer, the programming language doesn't really matter as long as you have the concept of the paradigm. Same like if you know Java, you can learn C# very easily because it's both follow the same one. And if you know the C#, you can learn Python, and you can learn Solidity, and it's all like following the same pattern. Yeah, you need to just spend some time with that, but then yeah. So Sawtooth have Python libraries, Python framework, SDKs with that, I think.
Getting more and more questions.
Okay, somebody asked about the graph data structure. That's the blockchain, we normally store it in a key value pair, that kind of way. Okay, if you're talking about Hyperledger Fabric, we store information into blockchain. At the same time, we keep something called state database. And the state database, there are two types of state database in Hyperledger Fabric. One is level DB and the other one is couch DB. The level DB is the default one with the Hyperledger Fabric, which is a very basic one. The couch DB, it's a bit more complicated. I mean, rich. We can use a rich query into that. But again, like when we are writing smart, when we are storing the information, we use like simple data structure, maybe a JSON file and stored using a key value pair. Not like I know that's the graph data structure we can use in the server side to the database. But try to make it like more simple. That's easier because when you're talking about the solidity and all, it's always like it's better to go for a simple data structure. Or key value means no, it's not. Key value means basically a unique key and a value. Value will be maybe a JSON object. So for example, like okay, yeah, it's me. The value will be JSON. Yes. Key can be anything. No, it's a data structure. Key value pair. What is like? It's like is it? I'm actually thinking like about the data structure. It's a dictionary or something. In dictionary, it's key value, right? In data science, something like that. Like you give a key and you put the value and you store into that place, and then give the key again, and then you get the value back. Like dictionary in Python. Yes, exactly. Yeah. The thing is, like if you know many programming language, you get confused with this data name. Yeah, exactly. Yeah. Any other questions? Oh yeah. Tell me about it. I have I did the Hyperledger Fabric 1.4, and then we had like some customers. It was up and running, and then the 2 came, and it changed completely. Because we use Azure. Azure had a template. We can create this whole blockchain network, and when it comes to the 2.3, it's very difficult. Now, I mean, it's not difficult, but the things have changed. Even if you wanted to try it out, like before we were using Ansible in the test network, but now then they use Minifab. It's completely different. This is a problem with the Hyperledger Fabric or any framework which is highly evolving like stage because it changes all the time. The first time, like they were using Composer to write the smart contract, and a lot of companies use as a Composer, and then they stopped supporting the Composer, and it moved into another one. So that's what I said, like you need to actually keep learning this thing. Otherwise, it's very difficult. That's the fun of it.
I think we have got like a lot of good questions, participants. So, yeah.
I was very, very happy by today's interactions, Rajesh. So thank you very much. Thank you, kids, Ramanpreet, everybody. You guys asked very good and pertinent questions. And as Rajesh said, please please connect on LinkedIn with him. He's doing some really, really great stuff. So I don't get impressed very easily, but today I was quite impressed by what Track Genesis is doing. I think it's a fun thing to have Rajesh on our panel of resource speakers. So thank you again, Rajesh. Thanks to everybody who's taken part in today's webinar. For all of you guys who are on today's webinar, we have a fantastic, superb speaker called Keshav Mishra, who is the head of digital banking strategy with Open Financial Technologies. He's coming on Friday to speak on DeFi or decentralized finance. It's a lovely session as well. He also is equally as good as Rajesh, and absolutely fantastic to have speakers like this on board with us for the Binance Ideathon. And last thing I want to say before we sign off today is, and I'll put my video also, please guys, please submit your ideas. It is very, very critical. For those of you who haven't, please submit your ideas. For those of you who have, please submit multiple ideas. This is an extremely amazing opportunity for all of you to get evaluated by Binance CXO and present to the management team if your idea has merit and value. And most importantly, you guys can win swag, you guys can win goodies and cash prizes as well. I don't know what's stopping you. You should just go for it. This is an opportunity that I4C has brought to you. We want you to take it with both hands. Thank you very much. Thank you very
Thanks very
much.
much, Deacon, and thanks very much, guys. So to
Thank you.
interact.
Thank you so much. Thank you for your time, Rajesh. God bless. Bye. Bye.
No
Thank you,
problem.
Saurabh.
Bye-bye.
Yeah,
Yes, bye.
thank you.